Okay, in this video I'm going to look at a few examples of cubic functions in factored form and how that will help us find zeros and graphs. So here's a cubic function in factored form, and you might be saying, well, how do I know that's cubic? Well, you can think about it. If you were to expand this, you have an x here, an x here, and an x here. So there'd end up being an x cubed term because you would have to multiply these all together. If you don't believe me, expand it. So you should be able to multiply these three binomials. And you would find that the highest power is a cube. So it is indeed a cubic function. So what we're going to do now is find the zeros, or roots, or x-intercepts. So to find the zeros, I set f of x equal to 0. So now it's very similar to when I had a quadratic equal to 0. I've got three things multiplied together to give me 0, which means that one of these three things must be 0. So x minus 3 equals 0, or x plus 2 equals 0, or x minus 1 equals 0, which means x equals 3, x equals minus 2, x equals 1. So these are my three x-intercepts. So that will help me graph. The other thing to notice is the order of these three factors. So notice the degree on each of these is 1 if there's no number there. The exponent is 1. So the degree of each factor, not degree, sorry, the order, that's the term we want, the order of each factor is 1. So what that means is when we do the graph, around the x-intercept corresponding to each factor, you're going to have, it's going to look like a linear, it's going to look like a line, meaning it's going to go through the x-axis. So we're going to actually cross the x-axis. So what I could do is I could put my three x-intercepts on. So I have one at 1, I have one at 3, and I have one at negative 2. Okay, so that's good. I have these 3 points, and I know that because the order is 1 on each of these, I'm going to go through it. What we also want to know is what's the leading coefficient, because that will tell me what my end behavior does. Do I go up as x goes to 0 or down as x goes to 0? And I know, so maybe I'll write this down below. So what about end behavior? Canada. End behavior is just determined by the leading coefficient. So I'm not going to actually make you multiply these, but all you have to think about is what if you multiplied the x terms? You'd have x times x times x, x cubed, positive x number. If there was a negative in front of one of these x's, or a negative out front, then you'd have to take that into consideration, which might make your a value no longer positive, depending on how many negatives you had. But in this case, we don't have any negatives, so we have a positive a value, which means our leading coefficient is positive, which means as x goes to infinity, f at x also goes to infinity. And as x goes to negative infinity, f at x also goes to negative infinity. Which means you're going to be doing something like this, and something like this. And now in between we know we're crossing the x-intercept, so you're going to go up and down and connect these points. One other thing you might want to do just to add some accuracy is to find the y-intercept. So y-intercept. To find the y-intercept, you just set your x value equal to 0. So let x equals 0. So y would equal 0 minus 3 0 plus 2, and 0 minus 1, which would just be minus 3 times positive 2 times minus 1, which is 6. So my y-intercept is 6. It's higher than I was anticipating. 5, 6, so way up there. Okay, that makes my... Maybe I should have done that first. So, I mean, that's terrible drawing, but that's the curve, basically. It might come down a little bit more. So that's how we'll sketch cubic functions. One thing to just be careful of is when you did quadratics, you wanted to find the vertex, so like where that turning point was, and it was always in between the zeros. That does not happen with cubics. So even though, like here, we have one at 1 and one at 3, so you might think, okay, the turning point must be at 2. Not necessarily true. Won't always happen with cubics. So for now, we're just going to have to estimate where that is. It'll probably be close to in between them, right? It'll be about 2, like I drew it around 2, but it might be a little bit more or a little bit less than 2. We're going to have to wait till we do a little calculus till we can actually find out where those turning points actually occur. So let's look at another example. So cubics can do a lot of different things. So let's do one like this. X minus 1, x plus 2 squared. So there's your factored form. So notice in this case, you've got x minus 1 has order 1, and x plus 2 has order 2. So that means this one's going to look like a linear near its corresponding x-intercept, and this one's going to look like a quadratic near its corresponding x-intercept. So let's find the zeros first. So 0 equals negative x minus 1, x plus 2 squared, which means x minus 1 equals 0, x plus 2 equals 0. If you want x plus 2 squared, but still, it means x equals minus 2, and x equals 2. Just for the sake of it, we could also find the y-intercept. So there we'll let x equal 0. So y is equal to minus 0 minus 1, 0 plus 2 squared. So we're going to have negative 1 times 4. So our y-intercept is 4. That will help for graphing. Then we could also think about end behavior. So all this is what we need to graph the function. So our end behavior, what is a positive or negative? Well, now we have a negative, and then we're going to multiply that by x, which will give us a negative number. Then we're going to multiply that by x squared, which will give us still a negative number. So our end behavior is a is less than 0, which means as x goes to infinity, f at x will go in the opposite direction, so to negative infinity, and as x goes to negative infinity, f at x goes to positive infinity. Okay. So we're going to use all this to put together a rough sketch of our graph. So first thing I'm always going to put on is my x-intercepts. So those were, one was at 2, and one was at negative 2. I can also put on my y-intercept. So 4. And now I know as x gets very large, I'm going down. And as x gets very negative, I'm going up for my end behavior. And now the question is, what happens sort of around here? X minus 1. Oh, this was a number 1, wasn't it? This was not a 2. I'm going to have to fix my graphs here. Okay, this was 1. So one of my x-intercepts is at 1, and one of my x-intercepts is at -2. That's better. And the y-intercept is at 4. Sorry, I misread that number. Still going down to infinity, and this one's going up to infinity. But now I need to decide what the function looks like around these x-intercepts. So the x-intercept of 1, that was this factor, this one here, that had an order of 1, which means I look like a linear around 1, meaning I'm going to go through that 0. So I cross the x-axis there. This one, the order is 2. So x plus 2, which was the x-intercept of -2, looks like a quadratic around it. So that means it's just going to touch and bounce off the x-axis. Doesn't actually cross it. So the cubic looks something like that. So order 2, you get one that just touches the x-axis, doesn't actually cross it. Third example, f at x equals, say, x plus 5 all cubed. So here there's one factor which has order 3. We haven't actually seen an order 3 factor yet. So the zeros occur when f at x equals 0, meaning 0 equals x plus 5 all cubed, which means x plus 5 equals 0, which means x equals -5. The end behavior, we have a positive, which means as x goes to infinity, f at x goes to infinity, and as x goes to -infinity, f at x also goes to -infinity. And the y-intercept, I'm not even going to solve this, but the y-intercept, you can figure it out, is a whopping, well, that's a pretty big number, 125. I'm going to have a fairly large scale on my x-axis. Yes, so x -5, so -5 is right here. That's my x-intercept. The order is 3, which means just like order 2 looked like a quadratic, order 1 looked like a linear, order 3 is going to look like a cubic, like that base cubic. If you remember a cubic, remember this one? F at x equals x cubed. That one looked like this, where it just kind of it touched, and it looked like it was going to sort of maybe turn around, but then it just kept going up. So that's what we're going to have, sort of this shape right at 5. So we're going to do something like just touch and then keep going up. So it's not linear because it's curved, so it sort of curves, and it looks like maybe it's going to do like a parabola thing and start going down, but it doesn't. It starts going back up. And then we're going to go all the way up to our y-intercept of 125. And then we just keep going up. So, I mean, this should be a bit smoother. It shouldn't sort of do this weird thing here, but generally, like, that's kind of what this looks like. It should be kind of more even. Not a great drawing, but the important thing I wanted to focus on was the order and the 0. So what happens there? So you have sort of a cubic looking thing going on there.